Hello geometry and welcome to 7.3 proving quadrilaterals are parallelograms. So let's start off with a little review first of what it takes to verify that you have a parallelogram. And before I do that, well, I'm going to go ahead and start in. So there are 5 key properties of parallelograms. The first one is the definition, which is that you have 2 pairs of opposite sides that are parallel. Thus, we call it a parallelogram. Ha ha! All right, so that's our blue. So that means this is parallel to that. That is parallel to that. All right, the next key property is you have opposite sides. I'm going to stop saying 2 pairs. You have opposite sides congruent, so they are parallel and congruent. So this is congruent to this, and this is congruent to that. So that would be, all right, I'll put it in here, 2 pairs of opposite sides congruent. Then that third property is we have opposite angles. So you have 2 pairs of opposite angles are congruent. So this angle is congruent to this angle, and this angle is going to be congruent to this angle. All right. Then what do we have? Let me see. We then have that 2 pairs of consecutive interior angles are supplementary. This one is kind of just a subset of the fact that you have parallel lines. But it means that you have consecutive, I'll just go ahead and write it, interior angles are supplementary. And that's not because it's a parallelogram, it's because you have parallel sides. So we know that like these two angles will add up to 180, these 2 angles would add up to 180, etc. All right. And then the last one we have involves the diagonals, so I'm going to go ahead and draw in our diagonals right here. Now, the diagonals are not congruent, but the diagonals do bisect each other. So in other words, they meet at each other's midpoint. So this segment equals this segment. I guess I have to give it a different there, and 1, 2, 3, 4. That segment equals that segment. Quite busy when you all look at it. Okay, so those are those 5 critical properties to show that it is a parallelogram. So basically what we have is then the converse of all of those properties. So this one says if your opposite sides are congruent, so we can just, if you were doing a proof, you could just say opposite sides congruent implies it's a parallelogram. And I always just draw myself a little parallelogram. All right, so notice they have the markings here. It has to be both sets of opposite sides. That makes it a parallelogram. Okay, then we have the angles here, the converse. And now we're talking the opposite angles. So if the opposite angles are congruent, then you can conclude that you have yourself a parallelogram. So this is congruent to this is congruent to this. It must be a parallelogram. Then we have, now this one is not part of the 5 properties. This one is sort of something that you can derive from those properties. So the way this works, if the opposite sides are parallel, one set of opposite sides are parallel and congruent. So notice here it's just, we don't know anything about those other 2 sides, but BC is congruent to AD, BC is parallel to AD, we can conclude it is a parallelogram. So when you have one set of opposite sides parallel and congruent, then you know you have a parallelogram. And the reason for that, if you kind of think about it, so the length here is fixed. The length here is fixed, and we know it's the same length. And we know they're parallel. The fact that they're the same length means that to connect these other sides, they're forced to be, no matter what angle you do it at, it's forced to be the same because of their being parallel and there being the same length. So that forces it into being a parallelogram. And we'll probably be proving that somewhere down the line here. Okay, then we have our parallelogram diagonals converse. And so let's see, we need a color for that one. Let's do purple. So again, this is a converse. And this one is saying that if your diagonals, if the diagonals are bisecting, so diagonals bisect each other, that is enough to show that you have a parallelogram. So notice again, they're not congruent. So that one is congruent to that. This one is congruent to this, but not all four are congruent. And this point where they intersect will end up being the midpoint of both diagonals. Okay, we're going to get quite a few proofs in this chapter. So let's kind of go through this one. So they've given us A, B, and C, D, and they have given us B, C, and C, A, D. Whoops, B, C should go with A, D, so this is a typo. This should be A, D. Sorry about that. All right, so that's going to be our given. So we have AB is congruent to CD, and we have BC is congruent to AD. We were given. Now, this next step will never make you come up with this, but this is just saying draw a diagonal to form triangle ABC and CDA. And you can do that because through any 2 points, there exists one line. All right, so where are we going to go with this? We're trying to show that this is a parallelogram, and we cannot use the theorem in the proof of the theorem because we're trying to prove that if you know the opposite sides are congruent, you know you have a parallelogram. And we're going to do it by showing we have 2 congruent triangles, and then show that the opposite sides will be parallel. So by definition, we have a parallelogram. All right, so let's start off. So I've got 2 pieces of information. My third is going to be my reflexive. AC is congruent to itself. You've seen that one quite a few times. So we know that this is congruent to ourself. Now because of that, I know that triangle ABC is congruent to triangle. Again, remember the order in which you write it matters. CDA, ABC, CDA. And the reason for that is going to be your side, side, side theorem. Now what I can do with that is, now that I know these 2 triangles are congruent, I know all kinds of angles are going to be congruent. So what I'm going to do is, I'm going to put some numbers in here because, you know, I'm lazy that way. I just would prefer to call things by numbers. So what I know now is that angle 1 is going to be congruent to angle 3, and I know that angle 2 is going to be congruent to angle 4, and what always follows from your triangle congruence is your CPCTC. Corresponding parts of congruent triangles are congruent, so I've got all kinds of congruent angles going on. Because 1 and 3 are congruent, that means that AB is parallel to CD, so that follows from there. And because 2 is congruent to 4, that means AC is a transversal. And that's going to give me that BC, I should put lines over these, is parallel to AD, and the reason for that is the converse of the AIA, alternate interior angle theorem. So if you have the congruent alternate interior angles, you know that the lines creating those are going to be parallel. So now I have opposite sides parallel, which tells me that ABCD is in fact a parallelogram. How do I know that? Because that is the definition of a parallelogram, to have opposite sides parallel. All right, so notice this was a very common theme or strategy in a proof. A lot of times you're going to somehow be proving two triangles are congruent. Use your CP/CDC to get other parts of those triangles congruent, which lets you then use a property such as parallel sides to get ourselves a parallelogram. All right, and let's continue on. Okay, so now we have some examples and we want to determine whether each is a quadrilateral, if each quadrilateral is a parallelogram. You might want to turn off the video and just try these on your own and then play it back to see if you got it right. So let's see, what do we have with this first one? We know that yes, it is, and if we had to justify, it's because you have one pair of sides, and these two, because this is consecutive interior angles are supplementary, that means these are parallel. One pair of sides is both parallel and congruent, would be the reason for that one. In this second one, you do have one pair opposite angles and one pair congruent, but not enough information in the format that we need it. All right, and this next one, number 3, is a definite yes, because you have the diagonals bisect each other. I'm just going to say bisect. All right, this next one is a yes, because we have opposite sides, two pairs of opposite sides congruent, so opposite sides plural. And on number 5, we've got odd. So you see one set of parallel, but notice you have the alternate interior over here, which means this is parallel to this. So yes, by definition, because opposite sides are parallel. And this last one, we can conclude yes, because this has to be 120 since they all have to add up. So we have yes, because opposite angles are congruent. All right, so that's how you would tell given a diagram. Now in this next example, it's giving us some information. So what we're going to need to do is draw ourselves a parallelogram. And we're going to want to put some numbers in here. So I'm going to start here. This is W, X, Y, Z. Angle W is 42 degrees. X is 138 degrees. Okay. And Y is also 42. And that means that out of 360, this would have to be 138. So this one we came up with what's left out of 360. Find the measure of angle Z. So we know that angle Z is 138 degrees. Is WXYZ a parallelogram? Yes, it is, because opposite angles are congruent. All right. And then we start getting into some of the algebra that you might have to do. So find the values of X and Y. All right, so notice this first one is going to involve no systems of equations if you do it wisely. So these two sides we want to be congruent. So we're going to set these equal to each other. I'm going to add X to both sides, or this X to that side. Subtract 6. So we know that X is going to be 9. And once I know that x is 9, so 2 times 9 plus 3, that's 18, 19, 20, 21. So we know that y will equal 21, so that we have opposite sides congruent. All right? This next one, if it's going to be a parallelogram, it means this piece, since the diagonals are bisected, so I can set 4x minus 11 equal to 2x plus 17. So we have 2x equals 28, x equals 14, and there is no y value in that one, so yay, we don't have to do it. Alrighty. Okay, so this next one, let's see what we have going on. AE, so let's find AE is x minus 15, EC is y minus 6, and BE, BE is 2x minus 10, DE is 3y plus 4. So what we have here is we're going to have to set up a system of equations. So remember, I have diagonals bisect each other, so I know that x minus 15 is going to equal y minus 6. And I like to have my x and y's on one side, my number on the other, so I'm going to convert this to x minus y equals 15 minus 6 is 9. All right, the other two, I have to set them equal to each other. So I have 2x minus 10 equals 3y plus 4. And I also am going to rearrange this so that it's 2x minus 3y, add 10 equals 14. All right, so now that gives me a system of equations to work with. Okay, now nothing can be added or subtracted right away. So what I'm going to do is I'm going to take this top equation and I'm going to multiply everything by 2. Actually, I'm going to multiply everything by a negative 2. So that gives me negative 2x plus 2y equals negative 18. And now what I can do is I can combine these two equations. So notice the x's cancel, and I've got negative 3 plus 2y is a negative y. 14 minus 18 is a negative 4. So that tells me that y is a positive 4. I can now take that and plug it back in. So I had that equation x minus y equals 9. So x minus 4, because y equals 4. So x is going to equal 13. And that would be your answer. Okay, so you want to set up the two equations. I like to organize x's and y's on one side, constant on the other. You have to make it so, well, I'm not a big fan of substitution, so I tend to do it by linear combination. So I want the same coefficient but opposite signs, so that when I add the two equations together, one of them will cancel out. Now our last one, show that ABCD is a parallelogram. Now this goes back to what we started with at the very beginning. Probably the easiest way to show that something is a parallelogram, again, you can use any of your methods. I'm going to use the one that says that the diagonals bisect each other. And the way to show that is I'm going to find the midpoint of each diagonal. So the midpoint of AC is going to be where I add my x values, so 2 plus 0 divided by 2, then the y values, 0 minus 4 divided by 2, so that gives me a midpoint of 1, negative 2. Okay, now let's find the midpoint of the other diagonal, which is BD. This will be a little bit easier because they have the same. So negative 2 plus 4 divided by 2, and negative 2 plus a negative 2 divided by 2, And so that's going to be 2 over 2 is 1, negative 4 over 2 is a negative 2. Notice that I have the same midpoint, therefore ABCD is a parallelogram because the diagonals are bisected. Now there's so many different ways I could have done this. I could have found opposite sides are parallel, so finding the slopes. I could have shown opposite sides are congruent by going through and finding the length of the opposite sides. I find showing that the diagonals share a midpoint, which means that they bisect each other. It means that this equals this and this equals this is probably the easiest way to go. This last page really quickly is just a summary of the different ways you can use to show that you have a parallelogram. You can show both pairs of opposite sides are parallel. You can show both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Show that one pair of opposite sides are both congruent and parallel. And then show that the diagonals bisect each other, which is what we did in that last one. All right? So these are going to be the 5 ways you can show that a quadrilateral is a parallelogram.